introduction about the topic that we are going to discuss today, and the topic is linked list. Okay, now there are various types of the linked list. So as per the syllabus, we will do only the singly linked list. Okay, and this is also one of the most important sections every year for 5 marks question. It do comes in your data structure part, that is section C of part 2 for 5 marks. Okay, so before I begin in details with all the classes, let me show you a video. Please watch the video. Okay, after that we will start discussing the further things. Okay.
Hello and welcome everyone to yet another tech enthusiastic video from Edureka. I'm Ravi and today we will be discussing about linked list in Java. So without wasting much time, let's quickly get started with the agenda for today's discussion. First, we shall learn what exactly linked lists are. Then, we shall deal with the types of linked lists. Later, we shall look into the important features of linked lists and the methods that are applied using linked lists. And finally, we shall understand the major differences between linked lists and arrays.
Before proceeding to the further video, please ensure that regarding the topic of your types of linked list, the theoretical knowledge is required. But for the practical implementations and all, we will cover up only the singly linked list. Okay, let's continue.
I hope I made myself clear with the agenda. Now, let us move into our first topic. What is linked list? A linked list is considered as a data structure similar to any other data structure like arrays, stacks, and queues. The linked lists have three major parts: head, tail, and node. Every node in the linked list is interconnected using the address of the next node. Before we get started with the linked list, let us understand the terminology of array. Before using an array, we actually reserve the memory blocks in the memory to store the data in order to process them. For example, I have reserved an array of integer data type and I'll be storing 5 elements into it. The name of my array is myArray and the addresses for the array are 0, 1, 2, 3, and 4. So now let us try to add the elements into my array. The first element is len. As you can see, the first element is stored in the index 0 of my array. Similarly, I'll try to add 4 more elements into my array, which are 20, 30, 40, and 50. As you can see, the data is been successfully inserted and the insertion order is been secured. Each and every
Okay, just to show you the concept of the array, as you can see that whatever the values are stored in the memory, they are in the linear data structure. Not only that, the memory address of each and every array is in the continuous memory location, because if your first value is stored at the memory address of 0, it will continue to get stored into the very next value, that is 0, 1, 2, 3, 4. So there is basically no gapping in between the continuous memory. Okay, so each and every memory are interlinked with a continuous structure. There is no gap, there is no randomly storage of the memory. Okay, so keep that in mind.
element is been inserted into the array in a sequential order, and now we can access them using their index numbers. But in case of linked lists, this doesn't happen. Unlike arrays, they do not work with the completely reserved sequential collection of memory. Instead, they choose the random blocks from the heap and store the data into it and provide access to the data whenever needed. The best part is, once the use of linked list is done, and if you won't need it, then you can actually dump the memory blocks back into the memory heap, which makes them reusable. Once you provide the data into the linked list, it will borrow the particular number of memory blocks from the heap based on the data type you provide. For example, 2 or 4 bytes for each block of an integer data type, and 4 bytes for each block of a float data type, and 16 bytes of data for each block of double data type, and so on. Each block it selects will have a memory address along with it and a space for data to be stored. Once the data is stored, then the last memory block will replace the address with a null value which indicates the end of the linked list.
Okay, just to show you this part. Okay, as you can see that each of these and were termed as a node. Okay, and every node has two particular segment. One part is known as the value, the data value, and the other part is known as the address value. Okay, now on the left hand side, if you can see the 10, this part is known as the data value. That means it is actually initially stored in the primary, the very first location of the node where the node is. Next you have the address value. That means your next value which is stored into the next node, the address of this next node is indicated by this. That means 1001 is nothing but the address of the next node where the value 20 is stored. So this 20 is indicated by this address value 1001. In the same way, if you continue, you can see that 1023 is written beside the 20. That means this is the memory address of the next node where the value has been stored. That means if you search 1023, that means which value is stored, value 30 is stored, and that is how it continues. Okay, now the easiest part of the linked list is that it has a random memory address. That is why the length of the linked list is also random. Okay, so that is why in array what happened, generally in the array you have fixed size. When you declare the array, you have to specify the size of the array. Okay, and that is why whenever you try to store any extra value which is whenever you try to store any extra value which is extending the length, then sometime what happens, the size of the array is overridden. That means that there is no further memory being allocated where you can store any extra value. But in the case of linked list, what happened, the size of the array is actually very random. That is why whenever you have to store any value, ensure that the node is actually taken from the memory heap which has been showed in the previous clip, as you can see. So that is why this is random. The size can be increased, the size can be decreased randomly. It does not have any botheration of having any effect with respect to the size. Okay.
Sir,
Yes.
do 10 has any address value?
Yes. Sorry.
Do do 10 has any address value?
10 do have an address value that I will discuss. That is known as the head node. I will discuss later. Now just see the video first. Okay. I'll discuss in details.
Using the interconnection between the nodes, the linked list behaves like an array and displays all the data in the form of a sequence. Now that we have understood what exactly a linked list is, let us discuss about the types of linked lists. The linked lists are majorly divided into three types: the singly linked list, the doubly linked list, and the circular linked list. A singly linked list is a standard linked list which mainly consists of two fields: the address space to store the address of the next node and the block for storing the data. As you can see, this particular node is the head node and this particular node is the tail node. This is the block which stores the address of the upcoming node, and this block stores the data. We can traverse in one single direction in a singly linked list. The next one is the doubly linked list. The doubly linked list is completely similar to a singly linked list, but the only difference is that the nodes in the doubly linked list have three fields, namely the address node for the next upcoming node, the memory block to store the data, and finally the block which stores the address of the previous node. As you can see, this particular node is the head node, this particular node is the tail node, and these nodes are the intermediate nodes which are lying in between the head node and the tail node. As you can see, this particular block of this node is pointing to its previous node, and this particular block of this node is pointing to the upcoming node. And this particular block is designed to store the data which you provide into it. This makes the doubly linked list traverse in both directions. Now, let us move into a circular linked list. The circular linked list is a singly linked list, but the only difference is that the final node address block is not ended with a null value. Instead, it points to the address of the head node. As you can see, in this particular linked list, the address of the first block is pointing to the next one, and the next to the next one, followed by which will reach the tail node. In the tail node, the address here is not none. Instead, it is pointing to the address of the head node. That's what it makes as a circular linked list. Now, let us discuss some important features of linked lists. The The important features of linked list are: first one is Q and DQ interface. The linked list implements Q and DQ interface. Therefore, it can also be used as a queue, DQ, or a stack. The next one is it can contain all the elements including duplicates and null. The third one is linked list maintain insertion order of elements. The next one is Java linked list is not synchronized. That means in a multi-threaded environment, you must synchronize concurrent modifications to the linked list externally. We can use collections.synchronized list to get synchronized linked list. Linked list class does not implement a random access interface, so we can access elements in a sequential order only. We can use list iterator to iterate the elements through the list. Now that we have understood the features of the linked list, let us move into the methods that we can use in the linked list.
Okay, so this is the basic introduction part of your linked list. As you can see that it is also a kind of a data structure to storage to store the values in the memory address. Okay, now coming back to the point, as I am going to show you in details what it is all about. Okay, so right now here is a presentation that I am showing you right in front of you. Okay, now as you can see the diagrams out here, now basically there are the three elements that you have to understand. One is the head, one is the value, one is the data, or sorry, value, the node, and the your address value. Okay, so these are the three elements that you have to understand. Now basically if you see is that each and every node, okay, if I can increase the size would be better. Okay, so as you can see each and every node is actually the combination of your data value and the address value. Okay, now the question comes is that how do they start? Now in the very first node, as you can see out here, the 5 has been stored. Okay, question comes that what is the address value of the 5? Okay, there is actually another node on the top of it. That particular node does not have any value part. The value part is null, and it has only the address value, which is actually indicating the first node, that is the beginner node or the head node. Okay, so always remember, it is absolutely important that whenever you are creating a node, no matter whether you have the value, whether you don't have the value, but every node has to have the address part, because the address part is actually the connector in between the multiple sequence of the node. So now the question comes, sir, then how is 5 is connected with the others? Now for the value of the 5, since this is a head node, always remember in the head node what happened, there is a virtual mode by default which is considered to be the memory address of the first node. That is why this is known as the virtual address memory also. Okay, virtual memory address is considered to be the primary memory address of the value which is present in the head node. I repeat, virtual memory address is that memory address which has the potential to store the value of the head node. So that is why
ये W तो मेरा वर्कशीट खुल जाएगा, खुल ही नहीं रहा है, क्या करना है इसको, तो कैसे खुलेगा?
Okay, so as you can see that all of these nodes are interlinked with each other. Okay, in the first part, as you can see, you have the value of 5. Now the 5 has a virtual memory address which is the beginner address. Okay, from the 5 onwards, the very next address, it is interlinked to the memory, it is identifying the location of the next value which is present in the next node. Okay, so this becomes the address part of the next node. So that is how, as you can see that in details, the theoretical part, a linked list is a linear data structure, obviously. Okay, nodes make up the linked list. Obviously the multiple connectivity of the nodes with the memory address are collectively known as the linked list. Nodes are structure made up of the data and the pointer to another node. Now this reference is actually with reference to the C++. That is why the keyword is pointer has been used. Okay, instead of the pointer, what you will use is the memory address, because the memory address is actually the common connector in between the multiple nodes. Okay. Now, before in details we discuss about the utility of the linked list, it is also equally important that we should understand the difference between why the concept of the linked list has been established, why the array has certain limitation, that certain application or certain implementation of the data. Am I audible, everyone? Hello. Am I audible?
Yes, sir.
Okay.
Yes, sir. So did you get disconnected in the middle?
Yes, I do get disconnected in the middle. It is possibly I was receiving some calls. Okay.
Uh, I thought my network problem is there.
Just hold on. Okay. So as I was showing you this particular part, it is also equally important that we should understand the differences. We should understand the differences between the array and the linked list. Okay. What is the first difference? Okay, the very first difference is that resizing is expensive and it has a dynamic size. Why the resize is expensive? Now, don't consider the term expensive to be related with any kind of monetary facts. Okay, what does it happen? Expensive means that every time if you have to alter the size of the array, the primary concept that comes is that you have to alter or change your program. Okay, you have to change the program every time. Like as we have already seen that in the single dimensional array, what happens? The size of the array need to be given during the array declaration. If you remember the concept, integer a array is equal to new, then the data type, that is integer, and in the bracket we have to allocate certain size that decides what the maximum size of the array. Okay, so that it can store up to certain amount of the value. Now, if you have to alter the size of the array, obviously it is necessary that you have to alter the size as well. Okay, if you suppose if your array capacity is of only 10 values, okay, but you want to store the 20 values, it is certainly not possible in the array. So array has this kind of limitation. Okay, and to alter the size of the array, not necessarily that it cannot be done, it can be done, but by the virtue of changing the entire program. Okay, so that means again you have to modify your coding, and with the help of the coding, what you have to do is that you have to change the size of the array. Okay, only then it is possible that you can store some large amount of the values in the array. But in the linked list was because in linked list what happened, although the values are arranged in the linear data structure, but the memory address are random. That means there is no specific size like array. There is no concept of the specific size which is given to the concept of the linked list. And thus what happened, since the linked list has a dynamic size, okay, by the help of this dynamic size, what happened, the value can be stored at any part of the memory address. And the big advantage of that, whenever you stored a value into a particular node, automatically what happened, the address part of your node get equal means parallelly it get activated just to see whether that particular node is indicating to the very next node or not. So as you can see that the value storage in the linked list is comparatively a lot more flexible as compared to the array. Okay, insertion and deletion is inefficient elements are usually shifted. Okay, as you can see, that means suppose you have the concept of four values. Okay, 2, 4, 6 and 8. Okay, now what happened if you have to shift, if you have to delete any value, or if you have to shift, if you have to insert any value, what happened? The size of the array is getting altered. That means what happened, if there is any kind of if there is any type of the value which is need to be inserted in the array or to be deleted in the array, generally what happened, obviously there is a size alteration, so there will be a memory alteration. So that means your shifting of the values generally get changed. That means if I had to say, suppose my value 7 is, my value 7 is stored in the third memory address. Now if I delete 7, then some other value will occupy the third memory address. Try to understand. Suppose, let me show you by an example. Uh, hmm. So let's see in this screen what is happening. Suppose I have an array. Okay, I'll make it little bigger for you. Okay, so you have a array where your values are stored. Let's say 2, 4, 6, 8, 7, 3. Okay, these are the values which are stored into the array. Okay, now what happened? Suppose if I am asked to insert any value in the middle. Okay, suppose in between 6 and 8 I want to store a value, say 9. Okay, that means what is happening? Okay, the value of 6 remains same, but the memory address of 8, 7 and 3 is getting changed because of the 9. Try to see very carefully. Okay, since I inserted the value 9 in the middle of the array, what is happening? My memory address of 8, 7 and 3 are getting shifted. So that is why that means what, when I have to insert any element in the middle while designing the code, I will have to keep the provision that if I am inserting any element in the middle, and then what happens, that I also have to keep the provision that whatever will be the new memory address for my 8, 7 and 3, those value also must get a memory address, otherwise this value will get lost in some part of the memory, or maybe occupied with a garbage memory value. So this is what one of the disadvantage of the array. Also, if I ask you that if I have to delete any value from this, so let us consider that I have to delete the value 6 from the memory address. Now if I delete it, now you can see that all the right hand side values are shifting towards the left hand side. That means this time what happened, my memory address of 9, 8, 7 and 3, all these four values, their corresponding memory address had also got changed. Okay, so this is one of the disadvantage of the array that which we have to keep in mind, that uh, since now what is happening, the basic application is that due to the insertion or the deletion of the value, there is the shifting of value which is occurring in the array. But for the case of the linked list, what happened, insertion and deletions are happening, but the values are not getting shifted. Try to remember, the values are not getting shifted. It's not that in my second node, if I have a number called 3 and the very next node I have a data called 7, then 7 does not shift towards the node of the where the value 3 has been stored. Okay, so this is what the advantage of the linked list is that the values which are present in their node, the values which are present in their corresponding node, it remains there. The values doesn't get shifted into the respective node while performing the insertion and the deletion operation. Okay, how it is the part of the practical assignment, so we will discuss this practically in the program. Okay, random access in array, what happened, the data security is comparatively less because randomly you can traverse the array and you can access any random value. Okay, this is the disadvantage of the array. And not only that, to perform any searching operation, what happened in some cases, if you remember, the values are necessary to be stored in a sorted order. If you remember that for the concept of for this binary search operation, it is necessary that your values which are stored into the array need to be arranged in a sorted order. Okay, so that thing is again a limitation in the array. But in the linked list, what happened, your values which are stored into the nodes does not require, okay, does not require any sorting operation. Okay, that means you can store any random value at any random address because all the values which are accessed from the nodes are done by the help of the memory address. Okay, and so what happened in the other case also, what you have to understand is that here the value from the value which are stored in the memory address are not randomly accessed. What happened, if you have to access the value in the third node, that means you have to go from the first node till the second node and then the third node. So that is why what happened, the data security becomes much more in the linked list concept as compared to the random in the array concept. Okay, in the array sometimes what happened, suppose you have allotted the maximum size in the array. Okay, suppose you have the array size of 30 but you are storing only 10 value. In spite of that, what happened, rest of the 20 memory address, but rest of the 20 memory are also remain allocated. Okay, now these 20 memories are actually getting waste because you are dealing with 10 values. In spite of that, you have occupied the 30 values in the array. Okay, you have that provision of storing 30 values in the file. So rest of the 20 memory space remain vested. But in terms of the linked list, what happened, in the concept of the linked list, what happens, your memory will only get allocated provided you store a value. Okay, so that means what happened, that there is no waste of the memory with compared to the array. That means in the linked list, always remember, whenever we need to store the value or we have to delete the value from the linked list, only that point of time the application of the memory address come into play. Now suppose we initially have stored 10 values in the linked list, that means right now only 10 values are actually occupied, not the 11th memory address. That means if I have to store any value, only then my next set of the memory address will get occupied, provided when we store any extra value to increase the size or to alter the size of the linked list. Okay, so linked list entirely depend upon the dynamic memory. Okay, that is whenever the application of the or the storage of the value is required, only then the memory address come into play. But in the array, what happened, no matter whether you store or you unstore, but if you have given the maximum size but still you are not using the maximum size, your rest of the memory remain occupied in the array. So this is the disadvantage of the array with comparison to the linked list. Okay, but what happened, since the in the array, what happened, your access of the data becomes faster because all the values are stored in the continuous memory location. It is not stored in randomly. So that is why your accessing of the data become much more faster in the array. but as compared to the linked list, at it is a little bit complex data structure, and also your values are actually stored in the different random memory. So that becomes what, that makes your coding little bit complex. Your system, your accessing of the value from the nodes become little bit slower as compared comparison to the array. But linked list provide much more better security as compared to the array. Okay, so these are the things that differentiate between the array and the linked list. Okay, we'll move on to the next link to continue our class.